Okay, so the first application that we're going to look at is acidity, pH. All right, so in chemistry, the acidity of a solution is determined by its hydrogen ion concentration. Okay, and the hydrogen ion concentration is denoted with these square brackets around the chemical symbol, with the plus to indicate that it's an ion. It's a positively charged ion. Okay, so this symbol right here represents the hydrogen ion concentration. Okay. And the way that we determine pH is given by this formula. pH is equal to the negative logarithm of the hydrogen ion concentration. All right, so let's just see how that works. So in example 3, we're told that the hydrogen ion concentration in seawater is 1.1 times 10 to the minus 8th moles per liter. And we want to estimate the pH of the seawater and then check our answer with a calculator. Okay, so we want the pH, and it's going to be the negative log of the hydrogen ion concentration, which is 1.1 times 10 to the minus 8. Okay, now 1.1 times 10 to the minus 8 is very close to 1 times 10 to the minus 8, which is just 10 to the minus 8. And what's the power of 10 that gives us 10 to the minus 8? Well, that's just going to be 8. Or sorry, yeah, it's going to be negative 8, and then we take the negative of it, so it becomes 8. Okay? So that would be our estimate. All right, so I'll put a little squiggle here to indicate that this is an estimate. Based on what I know about how logarithms work. All right. Now, if I put this into my calculator, here's what I got. I got 7.9586. Okay, that's the pH on a calculator. All right. So that answers example 3. That's all they're asking for. So let's go ahead and we might as well do example 4 at the same time here. Just using the pH formula. In this case, we're actually given the pH and we're asked to find the hydrogen ion concentration. Okay, so we're kind of in the reverse of what we were asked to do in example 3. But we could just put those values in our formula for pH, right? So the 3 has to be equal to the negative logarithm of the hydrogen ion concentration. Okay, so we have to solve now for the hydrogen ion concentration. So, well, let's just take the negative of both sides. All right, so I'm just going to multiply both sides by -1. And then I can I can use both sides. I could take 10 to the minus third, right, is equal to 10 to the log of the hydrogen ion concentration, right? And this right-hand side just becomes now the hydrogen ion concentration, right? Because they're inverses of each other. And so the hydrogen ion concentration is 10 to the minus third, which is going to be 0.001, and our units are moles per liter. All right, well, that takes care of our application to chemistry. And let's go on to the next example. I'll meet you in the next video.